Good afternoon, guys. My name is Deep Roy, and I'm a cybersecurity analyst at ICSS. And I have done many projects in network pen testing and web application pen testing. Also, in free time, I do some bug bounties. Also, I have found that many bugs. Also, like my interest is mobile for like forensics, right? Also, I have completed a global certification, that is CH. So today my topic is mobile device forensics, and today we will uncover some like how can we find some digital evidences like mobile forensics in mobile forensics. So mobile device forensics involves acquiring, analyzing, and reporting data from mobile devices. Like it's crucial for criminal investigations and corporate security incidents. In 2025, there are 5.5 billion smartphone users globally. So highlighting this is the most important field, that is mobile forensics. Now, first is the mobile forensics process. First, we need to know that how can we forensic a mobile phone. So the key step are identifying, preservation, extraction, analyzing, and reporting. Tools like Calibrite, UFED, Magnet, Axiom, and XRY are essential challenges including encryption, cloud-based data, and property systems. Right? Because in mobile forensics data, like if I want to get data from a mobile phone, then it is very much crucial to decrypt our mobile phones, right? So first is the mobile forensic process. First we need to identification. We need to check the mobile forensics, the mobile OS, that it is Android now or OS. Then comes under preservation. We need to the preserve our endpoints like the mobile phones. Then the extraction process. In the extraction process, we carefully extract the data from our mobile phone. What kind of data we can extract? We can extract some call logs, some messages, some WhatsApp message, some social media messages, right? Some call recordings. Also the processes. Okay. Suppose if any black hat hacker have like injected some malware in the victim's phone, so using some like processes, we can identify that what in the running in the back end of a mobile phone, right? So fourth number is analysis. So whichever we have find it in extraction process. Suppose the data like the call logs, uh, what WhatsApp, social media information, social media messages, and all the personal files from a mobile phone. Now we analyze this in a particular way so that we can present it to the court. And last one is fifth is reporting. So you need to make a particular report of it, all the steps like the identification process, preservation, extraction, analysis, and reporting. We need to make through this all the things, and now we need to create a report. In the report we will mention all the processes and all the things we have find it. Okay, like we need to mention the social media messages, like we need to make a column. In every column it will be like every other's columns, right? Like the social media column, here we find this kind of information. In call logs, here we find this kind of information, like that. Now mobile device data sources, like data comes from our internal sources such as call logs, SMS, app data, browser history, and GPS. External store include memory cards, SIM cards, cloud backups. Metadata includes timestamps, geolocation data, and file properties. So these are the manual mobile device data sources where we can extract some data from it, right? First is internal sources. In internal source means call log, SMS, app data, memory, like like the storage, right? Internal storage. It all comes under internal sources where we can extract the data. External sources mean the call logs and the information which is stored in the memory card. This kind of information we got from the external sources. And the cloud backup. What is the cloud backup? Cloud backup means if the victim is already stored some data in cloud, then it will be known as cloud backup, right? So if this kind of data we can get from this kind of data sources. Now challenges in mobile forensics, right? First is encryption and security features like iOS data protection and Android SE pose challenger. Rapid technology evolution and new OS update are also difficult, right? So like in features like iOS, right? iOS actually use some data protection, and in Android they actually use some challenges like SE both challenges also this. So rapid technology evolution, we know that in a current scenario, in today's scenario, we like our Android OS and the iOS is the most secure, right? So Android, like, it is the most secure version in iOS. We have 18.2, right? So everything is more secured, and they have the firewalls and the other things also. So it means that how can, if anyone encrypted their phone, then how can we decrypt it? How can we hack their passwords, right? So that is bit challenging our mobile forensics team. Now, privacy and legal issue include compliance with GDPR and the US Fourth Amendment also. So the encryption technology and legal issue, this is the most challenging for mobile forensics. Okay, so there is a way. Like, if the mobile phone is encrypted in Android, then there is a way we can decrypt it. So I will I will not show you in this live, but I can explain it. Then how can you do it? Okay. So in encryption, like Android, how can you decrypt it? If anyone have a password saved in Android phone, then how can you do it? If now I will show you the, like, I will tell you the mobile forensics process, that how actually the forensic team decrypt a mobile phone or hack their password, right? So actually what they do, if the mobile phone on their USB debugging, okay, the mobile is on their USB debugging, it means that we can connect USB and we can connect ADB. ADB is a software, okay, who can communicate with an Android phone. So using ADB and ADB using actually a USB, using USB and ADB, we can communicate with a mobile phone, and we can get some internal data also from it, right? Also, there is a still chance that you can install, if the USB debugging is on, you can install TWRP, and using TWRP means you can open a bootloader now, and now if you open bootloader, you can get some data from it, okay, some valuable data, raw data from bootloader. Also, like, you can inject some code here also in the bootloader, so that you can get the info. These are the challenges in mobile forensics. Like, technology also, it is a challenge, like rapid OS and device updates. A legal issue would be GDPR for amendment of compliances, right? Now we will learn that some of the techniques of mobile phone extraction method. Okay, first is logical extraction. Okay, so there is two part. First is logical and second is physical. So this, under three chief of JTAG and HIX terms, is comes under physical extraction. Logical extraction means using some software. If we can able to extract some data, so it will comes under logical extraction. And then in physical extraction, what we do, we actually use some physical hardware level technique, so that we can extract some data from mobile phone. Now, what kind of physical extraction you can do? First is chip off. It is the most unsecured and the most brutal way. That is chip off. So in chip off, we actually open our Android phone motherboard. Okay, and in the motherboard, we actually carefully chip off one by one memory. Okay, one by one memory we chip off, and after that we extract data from it. It is most critical one, and it can be chances that like your motherboard can damaged or something like that. Okay, so chip off is the most hardest one, and second is JTAG. Okay, so what is JTAG? So JTAG also comes under, like, using JTAG also you can fetch the data from an Android phone. What you need to do, you need to actual, like, you need to use some particular software so that you can extract data from JTAG. And last is hexdump. Hexdump means, what is hexdumps? Okay, also, like, before HDAM, there is also, like, you can also extract RAM of it. Okay, RAM of anything, like RAM of an Android phone. So if you disable a RAM and you get the RAM, you can get so many data from the RAMs also. Okay, also in HDAM actually what we do, like, everything actually we stored as a hex file, right? As a hex file. So using HDAMs, you can identify some data from a Android phone. Okay. Now, last one, legal and ethical consideration. Administratively standard include Dovet and Frye rules of evidence in court. Chain of custody protocols ensure forensic data integrity. Ethical challenge involve balancing investigation and privacy right. So actually, like, forensic team actually maintain these three part. First is accessibility. They do not like Dovet and Frye rules, and second is chain of custody. In chain of custody, we detect integrated protocol, like how can we manage it. So chain of custody also known as forensics, COC of forensics, because in chain of custody we learned some integrated protocol so that we can uh, you can protect the data. Okay, we can report it on the court. Now the ethics is balancing privacy rights. Okay, now is future of mobile forensics. So AI and machine learning are used in data analysis, and IoT device kept is emerging, and the projected market growth is 8 billion in 2030. Staying ahead of the rapidly advancing field is essential, right? So we need to learn this thing AI IoT growth so that we can update our skill and we can go to the top. Okay. So here to explain this one. Okay. So I forget to tell you what is JTAG, right? So we know the chapter now. We know the logical extension now. We know the HTML, but what is JTAG? So JTAG means like who like using this technique we can like get we can extract data from a Android phone, right? Like we can extract data from his RAM, his memory card, all the things comes under JTAG. Okay, then today's live session ends here. If you guys have any query, you can tell me. Also, like in the next class, we will learn another pen testing. Okay, then bye.